So hello everyone. Now we are going to analyze the third problem of the Leetcode 75 DSS series. This is the question contains duplicate. So we have to find out whether in this particular given array there is a duplicate element. That means if any value appears at least twice in that particular array, we have to return true. That means if any element is repeating, we have to return true, else we have to return false. Okay. This is a fairly easy question. So the array given is 1 2 3 1. Now here you can see that these two elements are the first and the last elements. One is repeating. Okay, so you have to return true. In this particular array 1 2 3 4, you have to return false because there is no element that is repeating itself. Okay, now let us come to the first example. 1 2 3 1 1 2 3 1. Okay, so what you can do is you can simply, the first solution that came to my mind was, of course you can use two for loops and then check if nums of I is equal to nums of j, and then return true, and after two for loops end, then we can return false. Okay, so this will give a complexity of around O of n square. So we need a more efficient approach than this. Okay, so when I was approaching this problem, then the first thing that, because I knew that O of n square is a very inefficient approach, so what the first efficient solution that came to my mind was, why don't we sort this particular array? Sort this particular array. So when we sort this particular array, then it will become 1 1 2 3. So if we sort this particular array, if there is any repeating element, then what will happen? Then that nums of I will be equal to nums of I minus 1. That means the current element will be equal to the previous element. Okay, if there is any element repeating and we sort that particular array, this will be the case, right? So if this case is satisfied, then we can return true, else we can return false. Okay, so how to code this approach? This is the second approach. I'm not going to write the code for the for loop, the n square approach. Okay, there will be two approaches that I will be explaining. This is the second approach, and the third approach I will be explaining soon. Now let us code this particular solution. So here the time complexity will be, as you know, we are using sorting, that's why time complexity will be n log n, and the space complexity will be O of 1 because we are not using any extra space. Okay, so we will be starting the for loop from 1. Okay, because as I've said, come to this here, if we start from 0, then nums of 0, this nums of I minus 1 will be nums of minus 1, right? So it will be array out of bound. That's why to fix this, I'll be starting this for loop from 1. Now what was the condition? If nums of I equal to nums of I minus 1, then we have not sorted the array. After this, so now this should work. So this it has been accepted. So we have first sorted the array. Okay, then we are traversing this particular array from index 1, from this index, so that we can compare this previous element. If there is only one element, it will always be false, because there is only one element, so it cannot be repeated, right? So you don't need to consider this that case, because ultimately if there is single element, then this loop will not be implemented directly. It will be returning false. That's why now we are starting this for loop from 1, suppose 2, then we are sorry, we sort this particular array, it will be 1 1 3. So here this is the second for first index, I equal to 1, and it will be compared with I equal to 0. So these two are equal, right? That's why it will be returning true. Now come to this 1 2 3 4. We will be starting from this. Okay, now these two will be compared with 1, it is not same. Then it will go to this index, it will be compared, 3 will be compared with 2, it is not equal. Then 4 will be compared with 3, it is not equal. That's why this will come out of this for loop and it will be return false. Okay, so this is how this approach will work. Now come to the third approach, okay, which is probably the most efficient one in terms of time complexity, because this is taking a time complexity of n log n. Okay, because the sorting algorithm, as you know, the average case complexity in most sorting algorithms like quick sort, merge sort, this is O of n log n. So now the third approach is that, why don't we store each and every element in a particular, say, box. Then that means we have to store each and every element while traversing the array. We have to store each and every element in some particular storage, and then we have to come while going to these future values, say x, y. While going to these future values, we can compare that if x is present in this particular box, that means if x has occurred previously, so the previous element will be stored in some storage, like, you know, what is the most convenient source of storage in C++, maps and sets. Okay, because the searching will be in O of 1, sorry, O of 1 time complexity. Okay, so that's why we will be using, we don't need to store any kind of mappings, so that's why we'll be using another set. So basically what I've said, that we have to compare if this particular element has occurred previously in the array. Okay, if it is present in this storage, that means it has occurred previously and it has been repeating, it is repeating. So then we'll return true. Else if until the last index, that is until the last element, if no element is repeating, that means no element is repeating in this particular array, and we will return false. Okay, so let us code. We'll be starting from the first element. So we'll be checking if s dot find nums of I. So if nums of I is already present in this particular set, then we will return true. Else we will insert each and every element into this particular set. Okay. If any of the condition has not been fulfilled, then it will return false finally. It should give correct answer. Okay, it is giving correct answer. So let me try run this. So in this case, the original, we are not modifying the array, right? 1 2 3 1 is the original array. So first we'll go to 1. We'll check that if 1 is present in this set. No, right? This is the first element, so nothing is present in the set. So we will this condition will not be fulfilled, so it will directly go to this. We will insert 1. Now what is present in the set? Only one is present now, till now. Okay, now we'll go to the second index, 2. We will see if 2 is present in this set. No, this condition again will not be fulfilled. Now again we will come to this, and now we will insert 2. Then set will look like this, 1 comma 2. Then we will come to 3. Again this condition will not be fulfilled. We'll come to this, and it will be inserted. Now while we come to this last element 1, we will check this, and the set will look like 1 2 3, right? 1 is present, so this condition will be fulfilled and we will be returning true. Okay, now in this second array, last element will be 4. So in this set, this condition will not be fulfilled, and finally it will come to this. 4 will be inserted, so this will go out of the for loop and will return false for this second array. Okay, that means this one false. For the first one, I have already told that 1 will be repeating. So this is how you have to approach these particular problems, and these are easy problems. In coming videos I will be solving some medium problems, because most of the time in online assessments you will be getting some medium the questions will be ranging between medium and hard. Okay, you won't be getting much easy questions. Even in interviews, face-to-face interviews, you will be getting medium range questions. You won't be getting very hard questions in the face-to-face interviews. You can get easy questions, but they will be asking the most efficient approach that you can tell. So you have to go from the inefficient approach to the efficient approach during the interview. So keep that in mind. Now thank you, and I'll be coming up with next questions soon. Okay, thank you.